Okay, so just to remind yourself how the correctives work, guys. Again, I know some of us keep forgetting how it works. You get half credit back for everything you correct. You're going to take a picture of your work, you submit it into Canvas. There's a submission for that right below the test. You have to rework every problem you missed and do it correctly. That's the point, right? It's correction. That means I expect you to ask me questions. So you can take a picture of your question you're on, message me in Remind, and just say, hey, how do I work this out? And I can real quickly help you for these real easy points back. So you can skip through this video. What I recommend you do, and I'll kind of give an example of this, is go through your test and write down all the questions that you missed. What I would do then is I would skip through this video because I have each slide titled with the questions that it's about. Again, your test is different than everybody else's because the questions get all jumbled up, but the question chunks are the same. So guaranteed that your questions 6 and 7 are going to be about this topic. So what you're going to want to do, say for example, you missed number 6. You would skip to this part in the video, and I'm going through number 6, and watch it and follow along. Go back to your test and try and fix your mistake and see if you know how to correct that question that you missed. And then you're just going to kind of keep going back and forth between this video and your test, watching the section that you need to. If you missed questions 11 and 12, you can watch this section later when I get to it. We're just going to skip through the video in order to do that. So I hope that makes sense. The key part here, though, guys, is just ask me questions, and this will go a lot faster. So for questions 1 and 2 to start with, this is just the vocab questions. So if you missed any of those questions for the vocab, all you need to do is recopy the correct vocab that tells you the answer, and you're going to get your half point back. That's fine. It's just straight vocab. So questions 3 and 4. So if you missed these, you probably accidentally went the wrong way or read the question wrong. The radius, there's a relationship here that the radius is half the diameter, which means the diameter is double the radius. So depending on what you're given, you're either going to double it or take half. So you may have missed this one if you just weren't careful about, oh, I need to double it, when actually you should have taken half. So I'll go over this example here, look back to your test and see if you can tell that's what you did. So for example, if we are given the radius, now I know it says radius is half. And so you want to go, oh, we're given the radius, take half. No, the radius is the half. So diameter is double this. So the diameter would have been 8. So if instead they said the diameter is 4, again, you read this and you see, oh, diameter is double, so double 4. No, this is the diameter, and we want the radius. You should take half here, divide by 2. So you have to be careful. Again, go back to your test and see if that's possibly what you did. I did see it on several of you guys where you doubled when you should have taken half. Be careful with that. Okay, question 5. So question 5, this was the only question that dealt with this picture where we wanted to verify if a line was a tangent. Now you may have gotten lucky because it was only, yes, it's a tangent, or no, it's not a tangent. But to be sure, what you had to do was you needed to see if Pythagorean theorem was true. So remember that Pythagorean theorem is a squared plus b squared equals this c squared. So what we did to be sure was we filled in Pythagorean theorem and saw if what we got on this side equals what we got on this side. So for this situation here, this is just an example, this wasn't on the test, my c has to be the biggest side. So 10 is going to be my c, but I want it squared. And therefore 2 and 9 are my a and b. So 2 squared plus 9 squared. So now we just need to compare both sides. So this is 100, that's 10 squared. This is 4 plus 81, that's 2 squared and 9 squared. Well, already we can see these are not equal, right? We could put a little not equal. So our answer for this question would be no, not a tangent, because it's not equal. It's possible if it was equal on both sides, we would say yes. So look back to your test, see if you can tell, do your Pythagorean theorem, see if it comes out to be a yes or a no. Okay, questions 6 through 7. So these questions have to do with central angles, which are the same. Guys, remember, central, same. As the arc they open up to. The tricky part with these questions, though, is there was one you could have gotten. You might have gotten lucky. If it was just straight, here's the arc, or here's the angle, there's the arc, and you're done. But a lot of these questions, you had to use other information in the picture to get your answer. So here's an example of having to use other information. Here's the center. So these are central angles, meaning that this angle is going to be the same as the arc it opens up to. But you have to focus on what we want. We want to find the measure of arc BD. So again, when you're looking at your questions on your test, ask yourself, what do I want compared to what information I have? Because all the information I have is that this is the center and this is a right angle. However, that angle does not open up to the arc I want. This angle opens up to this arc. So it doesn't help me too much, except that it does actually when we kind of put some stuff together from there. So to start with, this is a right angle. So how many degrees are in that? 90, and this is a 9-degree angle. Now, what we need to realize then is that if I know what this angle is, I can get this arc, right? I need the angle that opens up to that arc. So here's your line of thinking. Well, I know this is a right angle, and I also know that this is a straight line going through the center, and we call this what? The line going through the center of a circle. This is a diameter. So all together, this is 180 degrees. Diameter opens up to 180 degrees. So if this is 90 right here, what is that going to make this angle if together they make 90? It's going to be 90 as well. It will also be a right angle. That happens in the picture where you just see one right angle, but it's going to guarantee to us that the opposite side is also a right angle. So from there, we focus on the end prize. Our end prize is arc BD. If this angle is 90, then BD is 90 as well, and that would be your answer. So again, with 6 and 7, guys, be careful with those ones. Yes, the angle is the same as the arc, but you have to kind of follow a line of thinking. Well, I know this, which tells me this, which tells me what I actually want to find. So be very careful when you do those questions. Please ask me if you're confused on them, but go back to your test and see if you can figure it out. Okay, so 8 and 9. So these questions were about inscribed angles, which are half the arc. However, the pictures are a bit more complicated than this one. This is just a normal inscribed angle, right? The angle vertex is on the circle, it opens up. This angle would be 1/2 the measure of this arc. But these were the two pictures you had, possibly. You may have had 2 of these or 2 of these, but these are the 2 possible pictures you could have gotten for questions 8 and 9. So if you notice, there are inscribed angles in these pictures. This is an inscribed angle right here. And these are actually both inscribed angles. I know it looks like 2 triangles, but it's actually 2 inscribed angles that happen to open up to the same arc. So just looking at this picture here, because this one's a bit more easy to explain. In these ones, you were told what one of these angles is, and you wanted to find the other angle. These are actually the same because they are 2 inscribed angles that open up to the same arc. Yes, we could say, well, okay, if this is 30 degrees, that makes this arc double, because again, the angle is half of the arc, so I would double it to get the arc. And then I could think, oh, well, if this arc is 60 and this angle also opens up to this arc, well, the angle is half the arc. So this angle is also half of 60. So it ended up being that those angles are the same because they open up to the same arc. They are not the same as the arc, but they are the same as each other because they open up to the same arc. So that was that picture. So if you missed that one, the angles are the same. That's it. This one, however, you had to be careful about because if you notice, actually I should have done that. This inscribed angle and this central angle coming from the center, they open up to the same arc. However, they have different relationships. These were both inscribed angles, which is why they ended up being the same. But a central angle and an inscribed angle do not have the same relationship. For a central angle, we have it the same as the arc. For an inscribed, it's half. So what that means is, better actually go ahead and erase this. If this angle given to you was, let's say, 95, that's a terrible example, but whatever. It's a central angle. It's the same as the arc it opens up to. Now going backwards to the inscribed angle is half of the arc it opens up to. So we would take half of 95 there, which is like 47.5, I think. So what ended up happening here was a different relationship. This angle and this angle are not going to be the same. This smaller angle here is actually half of the central angle. And half of the arc, however you want to think about that. So again, if you missed that question, look back to the question. The important thing is to focus on what you are given and what you are asked to find. Do not automatically be like, oh, in this picture I take half. No, you could be doubling depending on what you are given. So be careful. Go ahead and go back to your test and check those ones, see if you can tell what you did wrong. Okay, so question 10, there was only one question like this. Now this question actually uses the same relationship as the inscribed angle does, which means angle equals half the arc. Even though it doesn't really look like a regular inscribed angle, it actually is. Now these ones are tricky though, because you had to use additional information. Again, guys, we can't just be one trick pony. We have to go, okay, because I know this, I can find this. So for example, if you were given what this angle is, this angle is going to be 1/2 of the arc it opens up to. Same as the inscribed angle. So for example, if this was 80 degrees, this angle, what is this arc going to be that it creates? Again, the angle is half of the arc. So what should the arc be? Double it. Again, the angle is half. So to get to the arc, we should double it to get the whole piece. So this is 160. However, it's possible the question was asking you for this arc or possibly this angle. These were tricky. So again, you might want to really ask me about this one. So if this angle was given to us, we could determine that this is 160, it's double. How could we figure out this green arc though? I know that this is 160 and the green arc is the rest of the circle. So how could we figure out how much is in the rest of the circle? Well, a whole circle is 360 and this arc is taking up 160. So that green arc would be 200 degrees. And then again, we could go backwards to finding the angle from there. If the angle is half the arc and our arc is 200, take half, go backwards, that would be 100. So here is everything you could find in that picture. Again, depending on the question, you might have needed to find the arc, you might have needed to find the angle, you can bounce around again a little bit differently, but that's the relationship at work in that picture. So take a look at what you're given in your question and see if you can figure out how to fix it from there. Okay, halfway through. So 11 and 12. So these two questions used this picture, which if you wrote your formula sheet, you would know that we have the angle is 1/2. What I wrote was arc plus arc, but it is very particular to which angle and arc it is referring to. So for example, if I want to find this angle, the two arcs that it's referring to are the arc it opens up to and the one opposite it. If I want to find this angle, it's referring to these arcs, the arc it opens up to, and again, the arc opposite it. So we had to be a bit careful here. If, for example, I was given angle 1 is, let's say, 35 degrees. Ooh, no. If I was given these two arcs, we'll go ahead and actually say that. If I was given these two arcs are 100 degrees, I'm just making up numbers here, and 50 degrees. That would only find this angle. If they asked you to find angle 2, which is possible, if they asked you to find angle 2, you're going to have to do something extra. You may want to ask me about this one. It has to do to the fact that what these two angles add up to together, because they make a straight line. But again, with these questions, you had to be really careful on what you're being asked to find versus what you are given. So this is the relationship. You may need to ask me, though, if you're still not sure where to go from there. Now, a warning in these next 4 questions. So 11 and 12, and then 13 and 14 have the same warning. If you're given the angle, so it says angle 1 equals, you're going to have to use some extra algebra skills to solve, because we have angle equals 1/2 the arc plus the arc. Look to your problems in your test. If it says angle 1 is blank, that would go here. Let's say angle 1 is 50. And then they might say arc EF is, I don't know, making up numbers here, 60. Find arc whatever. Well, we can't just plug in numbers where we want. Yes, it would be easiest if we knew both the arcs, but if the question says, hey, angle 1 is 50, it has to go in the position of the angle, and this is a bit trickier to solve because we have to get that arc by itself. So if you have a question that gives you the angle and you are thoroughly confused, let me know. I will help you out, because we need to know how to solve this. So questions 13 and 14, again, are a different picture. Now, there's one more picture here that you could have possibly gotten, but it's all the same relationship. The fact that the angle is 1/2, this is almost the same, but it is the outside arc minus the inside arc. So to start with, you had to understand what I meant by outside and inside. So if my angle is right here, the outside arc is the one furthest away from the angle. So in both these cases, this is the outside arc, right to where it touches right there on that line. Over here, though, this is the outside arc, just between those two lines. So again, the two lines just touch right here, so that's the outside arc. The inside arc is the one kind of trapped in between the angle and the rest of the circle. So this is the inside arc. So it's possible you may have gotten this wrong if you got the outside and the inside mixed up. You had to be careful with that. Now, this is the same warning as before, though. If you are given the angle and you need to find the arc, you will have a more complicated solving. You're going to plug into the angle position, and you're going to have to solve for something over here. So once more, if you go back to your test right now and you read angle 1 equals, and you're like, whoa, I don't know how to deal with that, ask me, send a picture, and I will help you get this set up and kind of go from there. You may need some help with this picture as well. But again, I'm just going to have you guys ask me. Please ask. Again, guys, like I've said, I am more than happy to answer questions. It tells me that you care. You are not bothering me at all. In fact, it's bothering me when you don't ask questions. Yeah, I want to help. I want to make sure you understand. So if you got this picture and you're not sure how to work with it, let me know. There is something special about that picture you might need. Okay, we're to the last chunk of questions finally. So 15 and 16. So for these questions, guys, these ones were really easy. I know we didn't have a ton of practice with it. If we were in person, we'd be able to practice it a lot together, and I could confirm and go, yep, that's the right answer. Yep, that's the right answer. Because the answers are there. You just got to do a couple little things. So the questions look like this. The question says, given the equation, blah, 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 the center coordinates are blank and the radius is blank. The answer is there in the equation. What you had to remember is that the center, so the answer is going to go right here, comes from the number in the x parenthesis and the number in the y parenthesis. That's your two answers. All you had to do was change the signs. Your answer for the center coordinates is going to be is going to be the opposite signs of what you see here. So if I see x minus 5, that means my first number is the opposite of minus 5. It's a positive 5. There's my answer. I'm done for that. For my second parenthesis, I see y plus 10. That means my answer is going to be a negative 10. Hey, there's two answers, yeah? There's our center. That again comes from the H and the K position, and then you're done with the center. The radius is a bit trickier though, because again, guys, the radius is just r. But in the equation, our r gets squared. So this is not r, and this was a lot of your guys' mistakes. This is r squared because that's the general equation. We want just the radius. So how do we undo a square? That's a square root. The opposite of a square is a square root. So this cancels out our square. Our answer is the square root of 144, which if you don't know that off the top of your head, you can use your calculator, but I know it, which happens to be 12. That's the square root of 144. So go back to your test, see if you can tell where you made your mistakes. A lot of you guys said this was your radius when you needed to take the square root. A lot of you guys used the same signs as here when you should flip the signs. I'm going to give one more example and then you can look back to your test here, because there was some questions where we didn't have a parentheses on one of the X's or Y's. So for our center being H and K, normally again, we take out the numbers we see here and just make them opposite. So I know at least for my second number, if I see -6 here, my second number is going to be a +6. Again, it's the second number because the number with the X gives us the first number. The number with the Y gives us our second number. But what's with X? Nothing. And what's nothing as a number? 0. So our first answer would have been 0. So if X and Y both have nothing with them in parentheses, our center is 0, 0. So pay attention to that again when you're going back to your test. Once more though, the radius here, the number given to you is r squared and we want just r. You need to take the square root to get just r. Hopefully you guys know the square root of 25, it is 5. So definitely back to your test. These are easy questions. It's just that we didn't have a lot of practice with them and so we got a bit jumbled up. Okay, the last questions here, 17 and 18. So 17 and 18 were still equations of a circle. You just need to pick the correct equation. In question 17, you're given a graph. In 18, you are directly given the center and the radius. So the only difference with these two is that in 17, you need to get the center and the radius off the circle yourself, but then we do the same thing. So I'm only going to show an example using the graph, because again, 18 is technically easier because they tell you the center and the radius, versus here, you have to count them from the graph. But then again, we do nothing else different from there. So we need the center. So they give us that point. What is that center point? Well, let's see. We got 1, 2, and then we're going down. So -1, 2, 3. So the center is 2, -3. Our radius, so you had to remember that the radius, the definition of it, is from the center to the outside of the circle. So the radius starts at the center, and then I can count in any direction to the outside of my circle. So 1, 2, 3, 4, 5. So the radius is 5. So again, in 18, you would have already been given that. So that's the only difference between the two. Now we have to pick the correct equation based on this center and the radius. So what we are doing is going in reverse of what we did in these two questions. So to pop into our formula here, if I see the radius, the center as 2, -3, that's again going to tell me what goes with my y and my x. However, if I pulled them out of my equation as opposites, when they go back into the equation, they also need to be opposites. So if I see a +2 here as my center, I need to make it a -2. If I see a -3 here, I need to make it a +3. So again, if we are pulling them out of the parentheses or putting them back into the parentheses, we need to change the signs. Now the last thing here, and again, this might have been why you missed it, this is r. The equation is r squared. So this is r squared, which happens to be 25. So again, guys, double check, go back to your test and see. You may have picked the answer that did not square the radius. If you picked an answer that just had a 5 right here, in the equation, we need to square the radius. So we count what the radius is, and then we square it. So again, guys, please ask me questions on any of this. I could have gone more in depth, but it would have made for an even longer video, and this is already a long enough video for you to skim through. So please ask me questions, and I can give you more clarification on some of the more difficult questions.